this part of the meeting, I would like to talk about heat harvesting in a building facade. As I already explained, and Christian has showed the PV technology, and also Diego has shown the ventilated window technology. The third technology we developed is actually heat harvesting in a facade. And if we look at electricity use of a building, about 40% of the energy used for a residential building is used for electricity, but 60% is for heating and cooling nowadays. So it's very important to find also solutions focusing at heat harvesting. And recently we have a spin-off company from the ENVISION project called Carlosol, which puts these heat harvesting panels on the market for buildings. So what we did in the project is apply these heat harvesting panels for 6 demo houses of social housing corporations. I'm going to explain step by step what the panels are, what the basic principles are, and how we demonstrated this, and what I also show some results. So the goal again is to use all the building surfaces for energy harvesting, but in a facade, it's like changing something in the face of a person. Aesthetics is crucial. And especially in that sense, we need architects to help us with that, to find the best and the nicest colors and solutions. Well, if we want to harvest solar energy, only part of the spectrum is visible to us as a human, which is the visible part, and the near infrared is actually invisible energy, as also is UV, but generally UV, we tend to protect us and materials from UV radiation because it's generally high energetic and damaging radiation. This invisible part of the solar spectrum to us is still about 45% of the solar energy. And we can use that for heating a building. So the basic principle is given in this nice schematic movie, where you see the sun is actually heating up the facades. And this energy is then used for a heat pump to generate tap water and space heating. And this space heating can be radiators, but can also be floor heating or any other methods of heating the indoor environment. And as Christian already explained, during parts of the year, the sun is really low, and then the energy on a vertical facade is quite high. So in spring and in autumn, the sun is quite low, and the amount of radiation of a facade is really high, and that's helping us generating heat. So now a short overview of the technology. What we developed is near-infrared absorbing coatings together with AkzoNobel, so we can make all kinds of colors. And we can make whites with 40% solar absorption. Normally white is about 2 to 5%. So that's a major step forward until we can go even to absorption very high, up to 100% solar absorption in case of dark colors. Now, then we have the coating, but we also need to efficiently harvest. So what we developed is panels, metal panels, where we optimize the heat transfer from the sun to the tubings connected to the system and the fluid behind the system harvesting the energy. So we not only designed the panels and the coatings, but also the installation with the heat pump toward the house. And of course, if you use such a system, we need special control systems to efficiently harvest and use the energy. So the main partners involved within the European project on this aspects were the best architects, the NB Architects in the Netherlands. Emergo is a prefab building company, which we are now together with them and Carlos Sol putting these panels on the market for all buildings. And then, of course, AkzoNobel for the coating and TNO as the research institute. And actually, I was the guy who, about 8 years ago, had the idea of doing developing this technology. So we are harvesting the energy from the panels and use it for tap water and heating. So a big step forward. And then you could ask yourself, which type of buildings can we use it? Actually, all buildings. Renovation, new buildings, industrial, residential, all is possible. And currently we are as far that we can deliver for large-scale projects these panels for the market. Many people ask the question, what are these panels delivering? Actually, the panels deliver the solar radiation, but if there's no sun, even the panels can get energy out of the air. So this means that the performance of the panels increases with the demand of your system. So if the heat pump is trying to get more energy from the panels actually give more energy because they take heat out of the air and of the sun. And of course, it depends on the color you choose and the orientation of the facade or even roof. Within a few years, we expect to deliver over more than 2,000 square meters per year. And we might even end up with this value already at the end of this year. We have a lot of potential customers from housing owners to project developer, contractors, social housing corporations. You can think of many architects, of course. Many people are currently very interested, and the big benefit is that we don't need to drill holes in the ground for ground loop as a source for a heat pump, nor using the air, which produces sound, but also is very inefficient in a part of the year where we have a very cold outdoor temperature. So firstly, we did a lot of extensive tests at the solar beat site at TNO. Here you see an example of the testing where you have regular PV in the roof and then these panels in the facade. Then we moved to demonstrations in 2 municipalities and 2 social housing corporations. In total, we used 4 types of heat pumps from 3 manufacturers, 2 installation concepts, and 3 different types of panels included in a special shed, which is a prefabricated shed with installation put over the house, connected to the house, and then you heat up the house. I have some movies to show this. We did on-wall mounting, but also on prefab wooden elements, which are completely integrated in the facade. So we had many research questions, also from technical point of view, but also most important is also to look for cost-effective solutions. Here you see one of the houses in Helmond. Here we use a prefab wooden house element. Another house where we mounted these panels. We only need about 15 square meters for a house. See some houses in Eindhoven, and here you see the shed. And this shed is actually it's nice to show. The shed has panels not only in the facade, so this facade on the side, but also this facade, but also the roof is actually heat harvesting panels. And on the roof of the house, we have the PV panels installed. Now, of course, you are very interested in the results. We're still busy because the setups are running since December. We're still busy with plotting all the data and understanding the performance of all the systems. But first, we tested all the houses. We already monitored the houses before renovation, and you see that last year in the Netherlands, on the 13th of February in 2021, we had the best testing winter. Unfortunately, this winter was not as great as last winter, but we still had a good amount of cold days, as you can see here in December of last year. So pre-renovation measurements and post-renovation measurements were done to really look at performance differences. Now, just a sneak preview of the results, which we will publish probably more at the end of the project of ENVISION in September of this year, where we also have then spring and summer data. But here you see that our panels can produce at the outdoor temperatures 18 degrees, about 50 degrees of solar temperature, and we expect during the summer to reach 60 degrees. It's stored in a big buffer vessel, which is on the right. And what you see here is that if you charge it during the day, during the night, it cools down. The heat pump starts heating up the house. And that's what you see here. The buffer temperature decreases, and the next day it fills. You see that we deliver a very high temperature to the heat pump, giving COPs way above 6, maybe 10 to 12, which is very efficient way of supplying energy. And what you also see in this diagram is that there's a period where there is little sun. You saw here a day where we have little sun, and then the energy is just taken from the outside air to heat up the house. Now, what you could ask is, what's the performance then of the panels? Well, the panels roughly have 15 square meters, and the performance of the panels even goes off the scale of probably 9 to 10 kilowatts. Unfortunately, I have to dig into the data to show this, but the graph scale is not high enough. You see here that we have solar PV production on the roof. We have approximately similar amount of square meters of solar heat harvesting panels, which give way more efficiency. You see the efficiency drops down here, so the panels do not produce here, and that's because our buffers are full and no more energy is needed to heat up the house or create tap water. So the last month, March and end of February, was a great month because we have sun and cold days. So during the day we have harvest a lot of energy, which we use during the night. But also in January, there's a month with the lowest sun this century. We just managed greatly to heat the 6 houses because we took the energy from the air, and if there was a bit of sun, that's also used. Then, of course, you want to know the economics of this all. In the end, the costs are lower investments than a ground source, so drilling a hole is more expensive than applying these panels. The COP are much higher than air heat pumps, and we don't have sound issues like you have with air heat pumps. Of course, the economics differ per country on many aspects, reasons, but also electricity prices. So if you would ask me what is the return on investment, then it's simple for the Netherlands, it's below 15 years. But for different countries throughout Europe, the economics are different because of different gas prices and electricity prices. 15 square meters is sufficient for typical ground road dwellings, but of course other houses are also possible. Of course, what we did is insulate the houses as well as possible to make sure that we reduce the energy demand. That's always a good thing to do. Use double glass, reduce your energy losses to your roof by better insulation of the roof and your walls. Increase the air tightness, and then we can easily use the heat pumps to heat the house, even with existing radiators, as we did in Eindhoven, where the buildings were from the 1960s. Well, the typical price is less than 8,000 euros if you consider the ground loop prices. But let's look at this great impression. We can just harvest from all the surface area, brown, white, including PV on the roof. The solutions are available to make houses energy positive. Let's use them. Apply them in the next upcoming renovation and new building projects. We can have year-round heating, and even without sun. We are actually currently looking also to cooling options, which all the system can also provide, which is the next project. And of course, by using this system, we can balance the grid by harvesting the energy during the day, store it in either buffer vessels or in floor heating, so that we do not put electricity on the grid altogether in the same part of the day. So we balance the grid, which reduces large-scale investments in the grids, which is needed for the upcoming years. I would like to thank many of the partners, not only the partners within the ENVISION project, but you see here also a huge amount of partners, contractors, social housing corporations, installation companies, and advisory companies, which helped us during the execution of the demo project in the Northern EU demonstrations of the ENVISION project. I would like to thank you for your attention, and I hope there's a large interest internationally also for these heat harvesting panels, and so we can supply them to you in the future.